The number one thing you have to remember now that we're working with more units, working with formulas, working with variables, is when we're combining things, we can only combine things that are alike. Okay. That means I can only add two things if they are identical quantities, or subtract. Multiplying and dividing, that's a bit of a different scenario, but again, I still only do the multiplication and division with the like quantities. So let's just get a refresher on that. Let's simplify these if we possibly can. So in the first one, I have 12y and 20y. These two things are identical to each other. So all I'm doing is counting how many y's do I have. So if I look at the front, 12y plus 20y, all I do is add the 12 and 20. This gives us 32 y's in total. Now, if I move on to B, I have y squared and y. They are being added. Y squared is something different than y. So these can't be combined, because they are representing two different things, even though it's the same base variable. If we multiply, it is different, but adding, they have to be exactly the same. So moving on to C, if I try to do 4y times 2y cubed, it's just straight multiplication because 4y is meaning 4 times y. So I'm going to multiply the things that are alike. So I'm going to start by doing the 4 times 2, which gives me 8. And then I want to do y times y to the third. So remember, when I'm multiplying something with exponents, they have the same base. We add the exponents together because all it's standing for is repeated multiplication. So on this y, that really is y to the first. So what that gives me is y, and then we add those two exponents, 1 and 3. Because really this is y, and then this is y times y times y, and we're multiplying them together. So in reality, this gives me 8y to the fourth. Okay. Same idea happens if I then, instead of use variables, switch to using a unit. So in D, we have 6 inches times 3 inches squared. So I just do the like things, starting with the numbers. 6 times 3 gives us 18. And then I have inches times inches squared. So I add those exponents together, and that gives us inches to the third, because there is a 1 here. 1 plus 2 gives me 3. Okay. So when we're dealing with these units, it's also often giving us some kind of measurement within an object. So we have 3 main measurements we're going to be thinking about, and then we'll also talk about a fourth one that's kind of relates to the second one here, but kind of combines two things together. So if you think about some kind of object, we have 3 measures to it. The first one is if I have a flat 2-dimensional object and I want to figure out what's the distance I would travel around it, that's going to give me the perimeter of the object. So the perimeter is represented with a P. Because again, it's going to change based on the shape. So if you think about that, if I'm walking around like a building, I'm keeping track of my distance. My units for this could be feet. The amount of feet I walked around the building. Or you can think of it as the amount of inches I walked around the building. Meters, miles, tons of things. You have lots of different units to describe a distance from one place to another. So all of these are always going to be units to the first power, just whatever your unit has to be for that problem. Could be centimeters, could be millimeters. But perimeter is a 1-dimensional distance. So it's always going to be just units. Now, if we move on though, and we talk about the space that a 2D object or a flat object takes up, this is giving us the area. So that's indicated with an A. Okay. So you can think of the amount of carpet you would need for a room is giving you the area of the floor in that particular room. So in this case, because it's a two-dimensional object, the units on this could be something like feet squared, the amount of carpet you need for your bedroom. Could be inches squared. Could be meters squared. Could be miles squared if it's something big. So any area is going to be whatever units you're working with to the second power. Okay. And then our third and final measurement that's rounds out these three is the amount of space an object occupies in real life or 3D. So this is called the volume. So often indicated by a V. Okay. So you can think of the volume of air in a room, the volume of water you need in a fish tank or a pool. These are always going to be units to the third. So feet cubed, inches cubed, meters cubed, and so on. So volume will have units to the third. Okay. So what we're going to do for the remainder of this section is we're really going to kind of look at just basic formulas that we have and go over, or basic shapes and go over all the different types of formulas we're going to be working with. So the first two we're going to start out with are triangles and rectangles. So in a triangle, you have three sides, hence tri. So we're going to label these A, B, and C. Perimeter is always the nicest one because all you do is add all of your side lengths together. So here, our perimeter would be A plus B plus C. Okay. Now, when I move on to area, we do have to be a little bit specific. So there's something else you often need, and you can kind of take liberty with our book. If it looks like something meets at a sharp corner, like down here, you can assume it's a 90-degree angle. So what we need is we tend to draw this little dotted line. We need two sides that form a 90-degree angle. So we call this H, okay? So in this case, I'm going to just rearrange these to make the formula something that you're used to seeing because it really doesn't matter what you call these side lengths. Let's say this bottom one is B, okay? So in our particular triangle here, B and H form a right angle. And that means this angle is 90 degrees, okay? So it forms a sharp corner. So the area is going to depend on these two particular sides that form the 90-degree angle. So here our area is going to be 1/2 B times H. You can think of it 1/2 the base times the height. So those are the two most important things in a triangle. So just to kind of show you though, a lot of times what you're going to see is there's going to be a clear-cut indication that there is a right angle within here, or even over here, you can assume that the angles here are going to be sharp 90-degree angles. Okay. Now moving on for rectangles, we have two different sides here. So the way a rectangle is classified is these two sides are equal to each other. And then these two sides across from each other are also equal to each other. And so it forms four sharp 90-degree angles. So every single one of these is 90 degrees. Okay. Again, it doesn't matter really what you label these. Let's say this is the length, and then these two sides across from each other are the width. When I go to find the perimeter, all I'm going to do is add up all of these side lengths together. So I really don't want you to put any thought into a formula or memorization for the perimeter, because we just add it all together. So W plus L plus W plus L. If I were to start here and walk all the way around, that's the distance I would travel. So you can condense it a little bit because you have W plus W. Well, you have two sides of length W and then two sides of length L. Okay. And then our area of a rectangle we've also talked about, but W and L form that 90-degree angle. So what we're going to do for the area is just multiply the two. The area is the length times the width. And that's actually where the area formula for a triangle comes from, because if you notice, if you cut this rectangle right down from corner to corner, it forms two triangles. So a triangle is half the area of a rectangle. 1/2 the base times the height. 1/2 the base times the height. So that's where that connection comes in. Okay. Now for rectangles, we can talk about 3D triangles. It gets a little complicated. So if you're taking some of our other classes, you'll see three-dimensional versions of that pop up. But at least for a rectangle, we can talk about that. So I'm going to go ahead and ghost in some other pieces of this. Let's use a different color to make it a little bit clearer. So this is a 3D shape. If you ever remember drawing these as a little kid. Okay. So when you have a rectangular box, the top and the bottom have exactly the same area. Then we have the left side and the right side have exactly the same area. And then the front and the back are also identical to each other. Okay. So typically when you have a 3D version, the bottom of your shape is one that's known. So in this case, the bottom is a rectangle. So we're going to label these two sides as L and W. Okay. And then we're giving it that third dimension that's typically called the height. So we'll indicate that with a capital H. So I'm going to skip over surface area first. We're going to talk about the volume. So if you think about this, the area of the base is length times width. And then I'm just going to kind of extend this idea to get my volume. I'm going to multiply it by H. So it's the area of the base times the height of that figure. So our volume, V, is LWH. Just multiply those three side lengths together. Okay. Now, what's unique about this particular shape for at least our class is we can talk about something that's the surface area. So area is still a two-dimensional object. So all that's talking about is the two-dimensional space this takes up. But because it's surface area, it's the two-dimensional area that each surface takes up added together. That sounds a little confusing. So a better way to kind of think of this is if I have this box and I want to figure out how much paint I needed to paint my box, then I have to go ahead and add up every single one of these faces or sides of my box together. So surface area we indicate with an SA. Okay. And let's start with the top and bottom of our box. So the top and bottom are two rectangles, and each of them has area LW because they're rectangles. So we have two sides with area LW. So that's how much paint we would need to paint the top and bottom of our box. Then let's go ahead and let's move on to the sides. So we've got one side here and an identical side over here. And each of these have area W times H. So we add that together because we would need paint for these two sides as well. So this is the left and right of the box. And then last but not least, we have the front and the back of the box, which again are two rectangles. So we have two identical areas. Then we've got side lengths L and H for this. So two sides of LH. So this is the front and the back. So this is the only one that you'll need to know surface area for. Again, we're not going to worry about all the other 3D surface areas, but this one you're really just adding 6 rectangular areas together. So again, I don't really like you to have to try to memorize the formula, but the concept of a surface area is just take the area of each side, add them together. Okay. So let's get some practice. Let's find the perimeter and area of each of these figures. So starting with our first one, we have a triangle. Again, perimeter is always going to be the nicest because all we do is add all of our side lengths together. Now it's going to be really irritating for you to have to write 3 inches plus 4 inches plus 5 inches to write that unit every single time. You can, because it definitely will make sure you don't make a mistake, but I'll show you how you can also get to the end result. So we've got 3 inches plus 4 inches plus 5 inches. And again, this does not change my unit. It is still inches because that's the distance I would walk around this shape. All I'm going to do is add these together. So 3 plus 4 is 7, plus 5, my perimeter is 12 inches, okay? And again, because I know it's perimeter, it's a one-dimensional thing, my units is just inches. So I really didn't need to write all of that out. Instead, what I could have done is just used those labels. So one side is 3, one side is 4, one side is 5. Adding those together gives us 12. And because I'm dealing with units, it's perimeter, it's 1D. My unit is inches, so I'll just add it at the end, okay? Now let's find the area. And our formula is 1/2 the base times the height, okay? And so what I need to do is I need to identify in my triangle which two sides form the 90-degree angle. So right here, my right angle is that. So that tells me 3 and 4 are what we consider the base and the height. So it's 1/2 3 inches times 4 inches. Okay. And so again, we just do all the multiplication. I worry about the units at the end. I didn't even need to write the inches in here. We'll show you that in a second. But if you do 3 times 4, it's 12. And then times it by 1/2, that's going to give you 6. So when I multiply the numbers together, it gives me 6. Then when I go to look at the units, we have inches times inches. So remember, that gives us inches squared. Okay. But again, I didn't need to write all of that. Instead, just use the numbers and worry about the units at the end. The base and the height are 3 and 4. 3 times 4 again is 12, times 1/2 gives us 6. And because it's an area and my units are inches, my area units are going to be inches squared. Okay. Moving on to B, the shape we have here, again, this is where you can kind of take some liberty that all of these are going to be right angles. So they are all 90 degrees, forming a rectangle. And so what that immediately tells me is that since this side is 9x, the side across from it is also 9x. And then here, because this one's 9x, immediately this one is also 9x. And really, since each side length is exactly the same, this is a square. It's a specific type of a rectangle. So when I go to find my perimeter, all we do is add all of these side lengths up. Again, no point memorizing a formula. But really, because every side length is the same, you're just doing 4 times that side, 9x. So I can only combine the things that are alike. I can do the 4 times 9, which is 36. And then I have a single x. Okay? Really, again, just treat x kind of like the unit here. And perimeter should just be that unit to the first power. When we move to area, all I'm going to do is multiply the 2 side lengths together. So we multiply 9x times 9x. And combining those like pieces, 9 times 9 is 81. And x times x gives us x squared. Again, just like you'd have an area, if x was inches, it would be inches squared. If x was feet, it would be feet squared. So x is just representing that particular unit we have. Okay. All right, so let's try some more complicated ones. We want to go ahead and we want to find the perimeter of this figure below. But if you notice something about it, we don't have every single side length, okay? So if I can figure out what this missing side length is, then I just go ahead and I add all of these together, okay? But I gotta figure out that piece first. So again, take some liberties. You can assume all of these are drawn nicely and that all of these angles here form that nice sharp corner of 90 degrees. So since this isn't any shape I particularly know, I want to break it down into shapes I do know. So you can dissect this a couple different ways, but I think the easiest one is just cutting it into 2 rectangles. So we've got one rectangle here, and then we've got a second rectangle over here. And 12 is going to be this entire side length. But since I split this into 2 rectangles, immediately I know that this side over here, just the small portion, is exactly the same. This has to be 5 centimeters, okay? Which then tells me this side here plus this one has to add up to 12. Immediately it tells me this side is going to be 5 centimeters or 7 centimeters because I'm going to take 12 and subtract the 5. So this side length is 7. Okay. And because again I have 2 rectangles, this is another rectangle right here, that tells me that the side across from it is also exactly the same. So my missing side length is 7 centimeters. And now that I have my missing side length, my perimeter is we add all of them together. So starting from 7, I'm going to go kind of clockwise, walking around this thing. The next side is 10, then 5, then 16. That entire bottom side is 12. I don't need to do 5, then 7. And then my last side is 6. So adding all of these together gives me 56. And again, because I'm working with a realistic measurement, it's perimeter. That means my units is just units to the first power. So the units here is centimeters. So the perimeter of this shape is 56 centimeters. Okay. Now for this next one, same kind of idea, but we're going to do area. So we are told a rectangle is removed from a right triangle to create the shaded region below. Find the area of the shaded region. So again, right triangle just means we have this big triangle here, and there is that 90-degree angle within it. Okay. So what I can do to actually find this is again break it down into shapes that I know. It doesn't make a ton of sense, however, to break it down into figures like this, because what is this side here? Sure, this piece here is a triangle, but I don't know about that other portion and I can't find it easily. Same thing if I do this. Yeah, I get a triangle up here, but what's this piece here? So instead, they're telling me a rectangle's removed from the triangle. So if I want to find the area of the shaded region, what I can actually do is start with this bigger triangle here. We're going to find the area of this triangle. And then we're going to subtract this little chunk we took out. So we need to figure out what the area of this itty bitty rectangle we removed is. So we subtract the area of the rectangle. So let's start with the area of the rectangle. That one's a little bit easier. Okay. The sides of the rectangle are 2 and 3, so the area is just multiply those two. So our area is 6, and then the units are meters, and it's area, so it's meters squared. Okay. Now I need to figure out the area of my triangle. Okay. And I know this is 1/2 the base times the height. The problem is my base is this entire thing, and my height is this entire thing. But these 5s are only representing that one portion. So this side length is 5, and this side length here is also 5. So I need to figure out what these two pieces are to get my total side lengths. But again, because it was a rectangle that was removed, immediately I know this portion here is 3 meters, and this portion here is 2 meters. So one side that forms my right angle has a total length of 8 meters. And then my other side here has a total length of 7 meters. Okay. And those are the two sides that form that 90-degree angle. So going through that multiplication, 8 times 7 is 56. Times that by 1/2. This is going to give you 28. And the units, again, are meters squared. So now that I have these two pieces, the area of my shaded region is the area of my triangle minus the area of the rectangle, giving us that the shaded region has a total area of 22 meters squared. Okay. So if you're ever unsure of the shape right away, break it down into pieces that you know. This is a common thing we do just in everyday life and in mathematics a lot. Break it down into the components you know. All right. So let's try one more type of shape, and we're going to talk about circles now. So this one's a little bit different because it doesn't have these sharp side lengths like all of these figures did. Instead, it's more fluid and it has this curve to it. So when we're talking about a circle, it has a very specific definition. You saw a pie circle or a pie chart when we talked about creating. You have some center to it, and then you have all of these points around it. So what actually happens for a circle is based on that center, this distance to the outer edge is a fixed number. So if you were to calculate the distance from here to here, it's one value, but it would be exactly the same thing if you calculate this distance as well. So that's what's super special about a circle. So all the points on the edge of a circle have the same distance to the center. The distance is given a specific name because it's pretty much the main thing that defines the circle. So the distance from the edge to the center is the radius, and we denote that with an R. So when I talk about finding the area or the perimeter or the volume of a circle, this radius is the only thing I really need. Now, you'll often also hear another vocab word related to the radius. So the radius is, again, just the distance from here to the edge of the circle. Okay. But if I go ahead and draw a line from side to side straight through the center, that's really the radius and the radius. So it's 2 times the radius. This is called the diameter, which is indicated with a D. So the distance from edge to edge through the center is the diameter. So we have a relationship between the two. The diameter is really just 2 times the radius. Okay. Now, perimeter, we like to reserve for these shapes that have these really rigid, sharp edges that come to a point when it meets another edge. A circle doesn't really have that. So instead of using perimeter to describe the distance that we would walk around the circle, we call it the circumference. So we use the circumference instead. So instead of using a P, we use a C to talk about the distance around the circle. Okay. So our formulas for both of the circumference and the area just depend on the radius. So the circumference is going to be 2 times the number pi times r. And pi is just a number you're going to see very frequently. It's about 3.14159, and then really it just keeps going forever. So 3.14159 is a good approximation for this. Be very careful in your directions. You don't want to do 3.14 as pi most of the time. You want to use the button that's actually on your calculator instead. Okay. Now when we talk about the area, it also involves pi. So it's going to be pi times the radius squared. Okay, so pi is just a number. Even though it's given this symbol, it's because it continues on forever. We can't write the full thing there. So these are just constants. R is the only variable in this equation. And so you can see you have just R, that's units to the first power, and r squared will get you that units squared that you need for area. Now when we move to the 3D shape, that's just a sphere. Same directions though. You just need this radius to define the sphere, and it's the distance from the center to any edge. Just looks like a ball, tennis ball, whatever you want to call it. So when we find the volume of a sphere, same thing, just depends on the radius. And because you need volume, you need the radius cubed. And so the constants that go out front are 4/3 pi r cubed. Okay. So let's just try one example. We're told a circle with a diameter of 30 meters is shown. We want to find the exact value of the circumference and area. And then using a calculator, we're going to approximate the circumference and area to 3 decimal places. Okay. So again, diameter is 30. That means the distance from edge to edge is 30. So our radius is going to be half of that. So half of 30 is 15. So the radius is 15 meters. Okay. So when I'm going to find the exact circumference, the exact value is 2 times pi times r. All I'm going to do is replace r with 15. So the exact circumference is 2 times pi times 15. And then multiplying the two things that are alike, 2 and 15 are. The circumference exactly is 30 pi. Okay? You leave pi as is because you want the exact value. Pi you can do a decimal approximation for, but if you want the exact value, the pi just stays attached. And then the units, because this is like perimeter, is just meters. So same exact thing for area. My area formula is pi r squared. So r is 15, so we do pi times 15 squared. 15 squared is 225. So we just like writing the pi at the end. This is 225 pi as the exact value of the area. And then because it's area, it's the units squared. Okay. So if you want the exact, these are the exact measurements of the circumference and the area. Now, if we want an approximation, this is where we go ahead and use the pi button or use 3.14159. So the exact value of the circumference is 30 pi, which approximately is 30 times 3.14159. So plugging that into your calculator, or again, just doing 30 times pi on your calculator and rounding to 3 decimal places, you should see this is 94.248 meters roughly. The area exactly is 225 pi, which using our approximation, we do 225 times 3.14159, which again, plugging into your calculator is about 706.858. And then the units on area are meters squared. So be very careful. Pretty much try to use the pi button solely. Don't do 3.14 for pi. You want more decimal places, so hit the pi button on your calculator when you're doing the approximations.